Hello, everybody. My name is Caroline. I'm the Soil Data Manager at Sensoterra. Today, I'm going to talk you through the Soil 101 presentation. The objective here is to talk about soil sciences related to Sensoterra sensors. So in case you are a reseller, please stay connected to this video. I hope you enjoy the presentation and let's get started. The title of this presentation is Soil Sciences: An Introduction to the Basics. As an overview, I will talk about megatrends, agriculture and smart irrigation, production and yield, results of optimized irrigation, soil types, so to talk about the texture classes, the necessity of a correct irrigation, plant available moisture per texture class, trends and tipping points for achieving max yield, and a glossary of terms in case you want to go and check some terms that we are talking here in the presentation. To start with the megatrends, 80% of the world's fresh water is consumed by agriculture. Of that, 60% is estimated to be used inefficiently. So we're talking about 60% out of 80% being some kind of water waste, which is a lot. At the same time, 75% of the world's soil is degraded somehow due to excessive water and nutrients runoff from over-irrigation. So we know that over-irrigation is a problem, and how can we find solutions using precision agriculture? Meanwhile, precision agriculture will reach $45 billion by 2024, and 15% of small farms did leverage a form of precision agriculture technology in 2019. So we see that the necessity for precision agriculture is there, and at the same time, less than 2% of agricultural land uses soil moisture data. So a really small percentage out of this precision agriculture and agricultural use are using soil moisture sensing. Now talking about agriculture and smart irrigation. Currently, 11% of global land surface is used for agriculture. So we're talking about around 1.5 billion hectares used for agriculture. At the same time, the necessity for efficient agriculture. So why do we talk about precision agriculture and irrigation? At this moment, that we have world challenges like population growth, also food security, and natural resources management, we have to invest in agricultural adaptation. And to invest in agricultural adaptation, we need smart irrigation techniques to be implemented. And of course, we cannot talk about efficient agriculture without talking about the importance of water as a natural resource for agriculture. So the role of water on soils and crops, it's extremely important for crop management due to being crucial for determining plant growth and plant development. So, for example, we see water throughout different phases, such as germination of seeds, plant growth, solvent for fertilizers and minerals. So the soil water availability or scarcity can mean successful harvest or limitation in yield. We're talking about problems when considering over irrigation, but also when considering under irrigation. So precision agriculture is there to combine soil health and natural resources management. Here we see a small sketch comparing on the left natural ecosystems and on the right agro ecosystems. We know that when talking about agriculture, there are natural pressures that the agriculture inputs they apply in the soil and in the system. So, for example, we have plant harvest, we have plant soil erosion, there are fertilizers and pesticides inputs that can eventually leach to the groundwater. So all of this, we are talking about optimizing natural resources to produce more yield, so grow more, waste less. So the importance of smart irrigation to make a better use of water and fertilizers applications. Now, when talking about production and yield, there are certain terms that are nice to understand when talking about production and yield. First of all, there is the actual production. What is the actual production? It's the actual yield. So it's the amount of agricultural production harvest per unit of area. Unit of area can be tons per hectare or tons per acre. The actual production is here, the first one, and can be limited due to weeds, pests, diseases, and pollutants. Now going to the limited production. So limited production is influenced by water and nutrients availability. So there can be limited factors to achieve the potential yield. So with proper measures, there is a possibility to improve limited production and extend it to potential production. And what is the potential production? Is the potential yield. So in an ideal scenario where there is a crop environment without pests, diseases, full of nutrients and full of water, enough water to be provided to plant health. So what we see is that there is a yield gap between the actual, the limited, and the potential yield levels. So how can we improve limited production to guarantee that we are extending our production to the maximum capacity, to the potential production? So there are different phases where Sensoterra sensors can be implemented and guarantee potential yield. So what we want to say here is that using Sensoterra sensors, we will ensure that you are going to give the right amount of water at the right time within different stages of your growth cycle, so you can increase yield. So the idea is to reach the maximum, to reach the potential capacity of your crop. And what are the results of an optimized irrigation? First of all, increase in crop yield. This is what we want. How can we increase crop yield? So produce more and waste less. When using optimized irrigation, what are the benefits? So you have better root systems, so you can achieve root systems health by giving the precise amount of water. Also, you control humidity in topsoils, so you know that you are not going to over irrigate or under irrigate. You control the levels of soil moisture, and also you can see less weeds because the soil is not as humid as it was with over irrigation. Now, also talking about the reduction of water, waste, and costs. The reduction of water consumption, compliant with government legislations with water restrictions. So we know that in different places there are water restrictions already happening as a pressure from the government. Reduction of inputs, so fertilizers, pesticides, herbicides, compliant with government legislations as well on leaching. Reduction of energy, so when using optimized irrigation, we're also talking about irrigation rounds, so less irrigation rounds, pumping machinery, resulting in more efficient supply chain. Also to better forecasting. So when you control the environment in your field with precision agriculture, you minimize the variability in forecasting on harvest yield, which enables farmers to find buyers in time. So you kind of know and can predict the healthy, if I can say, you can predict how healthy will be your crop when you give the right amount of water. And you can also improve soil health in general. Now going to soil texture classes. So here on the right, you can see the soil diagram, which is the soil triangle, known as the soil triangle, which can, depending on the position where your soil is, you can find any soil texture inside the triangle. So the triangle is based on the percentages of clay, silt, and sand, as you can see here on your left, top right, and bottom of the triangle. Nowadays, Sansaterra is working with 12 different calibrated soil types. So we have clay, saline clay, clay loam silt, loamy sand, loam greenhouse soil, sand, sand tree soil, sand planting soil, and sand dune soil 1 and dune soil 2. The reason why you don't see saline clay on the soil triangle is because saline clay is a type of, it's not considered as a physical property of the soil, but more of a chemical property, a chemical condition of the soil. So high salinity, so the amount of salt that there is in the soil, is due to inputs. So let's say can be fertilizers, pesticides, or herbicides, or when you apply water, when you irrigate your crop, the level of salinity that there is in the water. And also talking about the physical properties. The physical properties of the soil are related to the soil texture. So particle size and distribution will affect soil's capacity for holding water and nutrients. This is how we call the soil water holding capacity. So fine textures of soil will have a higher capacity for retaining water. On the other hand, sandy soils, which contain larger pores, will allow easier leaching and drainage. So will retain less water and will have a lower water holding capacity.